Confidentiality stands as one of the foundational categories within the trust services criteria, representing the organizational commitment to protecting sensitive but non-personal information. Unlike privacy, which deals with data linked to individuals, confidentiality focuses on proprietary, contractual, or operational information that, if disclosed, could damage competitiveness or trust. Within SOC 2, this category encompasses practices such as information classification, encryption, and data loss prevention, each of which provides a protective layer around information assets. The organization's promises to clients, regulators, and partners are reflected in these safeguards, ensuring that confidentiality is not just a technical measure, but a living part of governance and ethical responsibility. An information classification program is the first step toward managing confidentiality with structure and consistency. A clear taxonomy, often including categories such as public, internal, confidential, and restricted, creates a shared language for risk and handling expectations. Labeling and handling rules for each class guide how employees should store, transmit, and share information, whether inside email systems or collaboration tools. Automated tools can enforce labels and prevent mistakes, while periodic reviews ensure accuracy as data changes in value or sensitivity. Classification, when done right, helps teams make informed decisions about how to protect data before it becomes an incident response problem. Ownership and accountability give the classification system life. Every data domain must have a clearly identified owner, someone responsible for labeling accuracy, appropriate storage, and defining who should have access. Custodians, often within IT or cloud operations, carry out the technical side of enforcement. Escalation paths help correct errors like mislabeling or unapproved sharing, while staff awareness and formal acknowledgment make it clear that protecting confidential information is everyone's job. When these roles are well documented and reinforced through training, confidentiality becomes a shared obligation, not a compliance checkbox. Storage and transmission safeguards bring technical rigor to the policy framework. Encryption serves as the bedrock control. Data at rest should use strong algorithms such as AES 256, while all transmissions are secured through TLS 1.2 or higher. Segregating data by sensitivity ensures that confidential information is not commingled with routine operational data, reducing exposure. Secure transfer mechanisms, such as SFTP or managed file transfer systems, are used when sharing data with third parties. These controls ensure that information remains unreadable to unauthorized parties even if intercepted, turning encryption into both a preventive and detective control in the confidentiality domain. Bring Your Own Key, or BYOK, models extend this discipline into customer-managed environments. In these configurations, clients retain control of encryption keys used to protect their data within cloud platforms. This approach strengthens trust but introduces shared responsibilities. The customer must manage key rotation and loss prevention, while the provider must enforce boundaries and respect custody limits. Metrics such as key rotation frequency or incidents of failed decryption attempts provide transparency, and readiness reviews confirm that configurations align with both contractual and regulatory expectations. BYO turns encryption into a partnership where both sides share the burden and benefit of control. Access control for confidential data reinforces the principle of least privilege. Every user and administrator should access only what they genuinely need, following a need-to-know model. Quarterly entitlement reviews and post-role change audits help prevent privilege creep, while multi-factor authentication and role segregation protect critical systems from compromise. Logs of privileged access are reviewed regularly, not only to detect malicious behavior, but to demonstrate oversight to auditors. The combination of policy enforcement and technical controls builds a resilient access management environment, ensuring that confidentiality isn't undermined by human error or excessive trust. Data loss prevention, or DLP, provides visibility into how data moves across the organization. A mature DLP strategy monitors multiple channels, email, web traffic, endpoints, and cloud platforms to detect patterns that indicate sensitive content leaving its safe zone. For example, if a confidential document is attached to an external email, DLP rules may automatically encrypt it, block the transmission, or alert the security team. Continuous tuning is essential, as false positives can frustrate users and erode trust in the system. Over time, refining detection accuracy helps balance protection with usability, making DLP a smart, adaptive shield rather than a blunt instrument. Cloud storage and collaboration tools, while convenient, can easily become vectors for accidental exposure. Enforcing sharing restrictions based on classification labels ensures that restricted files aren't inadvertently open to external users. Anonymous links and public sharing settings are disabled by default, while access logs are monitored for unusual patterns, such as repeated downloads or access from foreign regions. Features like file expiration dates and watermarks add layers of accountability and discourage data leakage. These measures remind users that convenience must never come at the cost of control. Removable media and transfer controls deal with a surprisingly persistent threat: physical data leakage. Portable drives and USB media should be prohibited or at least encrypted, as they can easily bypass digital safeguards. Write protection and antivirus scanning policies prevent malware introduction, while device monitoring tools alert administrators to unauthorized insertions. When exceptions are necessary, such as for manufacturing or engineering workflows, they are documented with compensating controls to preserve traceability. Even in the cloud era, these physical safeguards remain an essential line of defense. Data redaction and masking techniques are crucial for environments that need to process or test data without exposing sensitive elements. Fields not required for a given transaction can be anonymized, while tokenization allows for reversible substitutions when traceability must be maintained. Validation steps ensure that redacted data cannot be re-identified through pattern analysis or accidental inclusion in logs. Routine testing of these mechanisms helps confirm their completeness. In practice, data masking allows organizations to innovate safely. Developers, analysts, and third parties can work with realistic data sets without compromising confidentiality. Retention and disposal discipline closes the lifecycle loop. Every data class must have defined retention periods based on business, legal, and regulatory needs. Automated deletion policies prevent forgotten archives from turning into liabilities, while detailed logs confirm when and how data was destroyed. Dual authorization for permanent destruction ensures accountability, especially for backups and archives. When deletion is verifiable and repeatable, organizations reduce the risk of unintentional retention, protecting not only confidentiality but also compliance posture. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Third-party confidentiality alignment extends an organization's control environment beyond its own walls. Every contract involving external vendors or service providers should include explicit confidentiality clauses defining encryption standards, data handling obligations, and notification requirements. These expectations are verified through due diligence and continuous monitoring, ensuring subservice organizations implement encryption and DLP measures equal to or stronger than the primary entity's own. Regional or role-based access restrictions should reflect contractual promises, and each year, evidence of compliance, such as SOC 2 reports or security certifications, should be collected and reviewed. This continuous verification ensures that confidentiality commitments flow downstream, preserving trust throughout the service chain. Incident and breach handling procedures provide the safety net for when confidentiality controls fail. Not all incidents are catastrophic breaches, but all must be classified accurately to determine their severity and response requirements. Communication workflows ensure timely notification to stakeholders, regulators, and customers, while containment actions stop further exposure. Root cause analysis examines both technical and human factors, followed by corrective measures that prevent recurrence. Afterward, encryption effectiveness should be validated to confirm that data protection mechanisms performed as intended. This cycle of detection, response, and reflection transforms incidents into learning opportunities and reinforces the organization's maturity. Monitoring and alerting capabilities create the visibility that confidentiality programs depend upon. Centralized dashboards aggregate data from DLP, encryption systems, and access logs, providing a single view of information protection posture. Alerts should trigger for anomalies such as unusual file transfers, sudden permission escalations, or mass data downloads. Each alert prompts an investigation, and the results are documented for trend analysis and audit readiness. Over time, tracking false positive rates and response times provides operational insight, helping teams refine both tooling and human procedures. When confidentiality can be measured, it can be meaningfully improved. Evidence expectations for confidentiality are well defined in SOC 2 examinations, serving as the backbone of auditor assurance. Policies and training records demonstrate that the organization has formally communicated its rules. Encryption configuration exports, key management logs, and DLP incident tickets offer direct technical proof. Destruction certificates and retention settings show lifecycle control, bridging policy to practice. A mature evidence library doesn't just satisfy auditors, it gives management visibility into where gaps exist, enabling proactive strengthening of the confidentiality program long before the audit clock starts. Metrics and key risk indicators, or KRIs, quantify the performance and resilience of confidentiality controls. These might include the percentage of assets and transmissions that are encrypted, the accuracy of DLP detections, or the average time to rotate encryption keys. Tracking access review completion rates, or exception volumes, helps assess procedural discipline. Meanwhile, measuring incident closure times highlights operational responsiveness. By tying these indicators to risk thresholds, organizations move beyond checklists and toward a measurable, continuously monitored control environment that reflects genuine assurance. Training and awareness reinforce confidentiality at the human level where most leaks begin. Role-based learning modules teach employees how to handle restricted data, identify sensitive classifications, and respond when something looks suspicious. Real-world examples of misclassification or accidental leakage bring lessons to life, helping staff see the impact of small mistakes. Annual acknowledgment of confidentiality policies reinforces accountability, while refresher sessions after incidents ensure that lessons learned are embedded into culture. A well-informed workforce is the best defense against both negligence and malice. Automation and integration amplify confidentiality by linking technologies into a coherent ecosystem. Data loss prevention systems, cloud access security brokers, CASBs, and security information and event management (CM) tools can share intelligence to detect correlated risks across the environment. Automated classification tagging through metadata eliminates manual steps, ensuring consistent labeling across cloud platforms and repositories. APIs allow encryption verification at scale, confirming that sensitive data is properly protected wherever it resides. Scheduled governance reports close the loop, giving leaders ongoing visibility into compliance performance without waiting for audit cycles. Common pitfalls in confidentiality programs often stem from inconsistency and overconfidence. Labels may be applied inconsistently, DLP rules unenforced, or encryption keys stored in shared repositories. Overly permissive sharing settings and collaboration tools can expose entire directories to the public without anyone noticing. These weaknesses are not purely technical. They reflect process and accountability gaps. The solution lies in automation, periodic reviews, and a clear sense of ownership. When data owners know they are responsible for the security of their domains, confidentiality becomes part of operational discipline, not just IT configuration. Maturity progression in confidentiality management follows a natural evolution. Early-stage programs rely on manual classification and periodic reviews. As automation increases, systems begin applying labels and enforcing rules dynamically. Real-time DLP emerges, responding to risky behavior as it happens. Eventually, organizations integrate encryption analytics and key telemetry, using dashboards to identify weak points or missed rotations. At the highest level, confidentiality controls merge into continuous compliance frameworks, where monitoring and reporting are ongoing and adaptive. This maturity curve represents the journey from awareness to assurance. Cross-framework alignment helps organizations leverage work across multiple audits and standards. SOC 2 confidentiality aligns closely with ISO 27018 for cloud privacy, as well as NIST's SC, System and Communications Protection, and MP, Media Protection controls. Mapping to SOC 2's common criteria, such as CC6 on access management or CC11 on vendor oversight, shows how one set of controls supports multiple trust principles. By designing confidentiality evidence to meet these shared expectations, organizations reduce audit fatigue and strengthen their overall compliance narrative. Integration also ensures that privacy and confidentiality reporting flow from the same factual foundation. Cultural reinforcement ensures that confidentiality remains a living principle, not an annual training topic. Leadership should speak openly about the importance of secure data handling and model good behaviors in their own practices. Recognizing employees who demonstrate vigilance, such as reporting potential leaks or improving labeling accuracy, builds positive reinforcement. Communicating lessons learned from incidents fosters transparency and trust, while linking confidentiality metrics to performance reviews or team bonuses gives the program tangible value. Culture, more than policy, determines whether confidentiality thrives or fades. In conclusion, the confidentiality category under SOC 2 embodies the principle that sensitive information must be protected throughout its entire lifecycle. From classification and encryption to DLP and disposal, each control area reinforces the others in a tightly woven system of governance and technology. Ownership, automation, and evidence discipline turn policies into operational reality, ensuring that commitments made to customers and regulators are continually upheld. As organizations mature, confidentiality evolves from a static rule set into a continuous, measurable practice that supports not only compliance but lasting trust.